Hello everyone, this is Farooq here. I hope you're doing well. I am not kinda good. I'm looking for a job. I didn't find a one. So, whatever, let's get to the video. Today we're gonna make an application, I2C application on STM32F4 with OLED screen. So first I wanna talk about some I2C communication and then we will go to code side. And I2C there communication, there are two bus, SDA for data, SCL for clock. So all devices is connected to these two bus, and every slave has unique address, as you can see beside them, and it can be more master. So master can be same addresses or no, it depends. But slaves have to be different addresses. It's because the master have to choose a slave, which slave it should communicate. Because of that, slaves has unique address. And bus also there are two resistors. It's pull-up resistor that is pull-up because they are connected to VCC. If the resistors connect to the ground, we say pull down. If they connected to VCC, we called and pull up resistors. These resistors actually for open drain. I will explain also this. And let's get to the code side. Let's look before the code side. Let's look at data frame. So the data frame of I2C is like that. First we send to the start condition. The start condition in this condition is like the master say I'm gonna start the communication, and its SDA will go 1 to 0 and the communication starts. The 7-bit address is the slave address. As I said before, it's unique for a slave. And 1 bit, is it gonna be read or write? This is 1 bit for it, and 1 bit also for acknowledge. So if for example we find the slave, we just send the data, slave should be acknowledged back, like it say yeah, it's me, you will send data to me. If there is no slave or something, there's like error or something, this bit will send back and not acknowledge NACK. So this bit actually for it, this for that. So the 7-bit is for the data, and when the data also sent, there is also the last acknowledge bit, then the stop condition. So the I2C communication, let's look at the reference manual of STM32F4 nuclear board. There are 4 communication actually, 4 modes, not communication, sorry. The slave transmitter, slave receiver, master transmitter, master receiver. In this application I will just use master transmitter because we will send data master to slave. We will not get back data slave to master. But the other videos I will show all of them in the other videos. And also as you can see that it's and protocol how to data frame and acknowledge bit. And also as you can see that I2C communication is most significant bit communication. As you can see, it starts with the most significant bit to send. So let's get to the code. Before we write the library for I2C, so first we should enable the clocks. and I2C clock and the GPIO clock. I took a video about RCC and it's in my channel, you can check it out. So the I2C1 is connected to APB1, so we should enable APB1. I2C1 is the 21 bit. So when we look at this, you can see there's a 21 bit, we just give them 1. And then for GPIO, general purpose hub, we have to also enable the clock. And the I2C, we will use I2C1, so the pins are GPIO B8 and GPIO B9. So it should be GPIO B clock. I didn't see where. Yeah, no, it's not there. Oh no, sorry for that. The clocks also is there for AHB1, I think. Yes. So let me look. GPIO B register we will also enabled. This is the 1 bit. When we, as you can see, it's 1. So after the clock things, we will work on GPIO registers. Because yeah, fun. So as you know, you have to set GPIO is like, is it input, output, or like analog mode. But if we are using an I2C or any other things, or like SPI or something, we should say that it's an alternative function mode. So this is an alternative function mode, and we were using PB8 and PB9. So we will just give them a 1 0. So we just give them 2, right? 1 0. So before they give them, it should clear the data. It's because of previous values or something. It's for, I think, security things. If you do that, it's gonna be better. So we just give them 2, just say it's an alternative function because we're using I2C. So after that, we will use, of course, open drain, because I2C communication, it's open drain, not an push pull, not push pull. So we are using an 8 and 9. We just give them 1. 8 and 1. We just give 1, and the speed. We'll just use fast speed. I will just give 1 0. It means 2 to 16 and 18. As you can see there. Oh, sorry. What is Q there? It's 4. We just give 3. Let me look. We didn't use an fast speed. We just use high speed there. We just, because we give 3, as you can see. But you can use fast speed. It's not gonna, I don't think it affects so much. Actually, if you choose fast speed, it's not gonna be like noise on any things, electromagnetic interference. But if you choose high speed, it's gonna be more ME. So I don't think you can just choose one of them. It's not gonna change so much things, I think. And let's get the we just select the speed, GPIO speed, and we just, as I said before, we just use pull-up resistors. So it's an internal pull-up resistor. It's in on the board. So we just give 1 actually to 16 and 18. As you can see there. And let's get to the alternative function side. So before that, I have to open alternative function. Yes. So as you know, I2C1 we will use PB8 and PB9. So the pins 8 and 9, it's there. So we will use AFR high H, the high one, not the low one. And we were using I2C1. As you can see, it is AF4. So keep in that mind. So let's look at the register alternative function, high register. So in that we were using 8 and 9, and as I said before, they are A4, so we just give them A4. So you can just write here an H or like this. This is means an high AFR H. It's an high. So as you can see, we just give 4 to 0 and the fourth bit. So after make this is the GPIO part is finished. We will now configure the I2C part. So let's go to the I2C. Also, let me, as I said before, there are two modes. I will use master transmitter. You can see there also just saying the required sequence to use. I actually follow this part. So let's get the register. So I2C register first. We have to we will configure the I2C. So first we will just disable. We just configure and then enable. Okay. So we have to disable first the I2C peripheral. It's the 0 byte, and we just disable it. Okay. So in there we just disable it, the configuration, to make a configuration. So after that the I2C1 connected to APB1, the main clock. I will put the graph there in this video. You will see it, and you will see that the frequency of the APB1 clock is 45 megahertz. So I2C also the peripheral should be 45 megahertz. And as you can see that the control register, the frequency, there are first 6 byte, and the minimum allowed frequency is 2 and the maximum is 45. I will use the maximum one, so it's gonna be 45 megahertz. So for the standard mode, and let's let me, I actually for this clock control register, I will just give the data to ChatGPT, and it just give me the clock register frequency and T-rise value or something. But I think there is also calculation in there. Let me look. Yes, as you can see there, for clock control register we were using a standard mode. We just give this bit 0. So to standard mode, there is an, as you can see, there is an equation there. So we will just use this equation. I will also put this calculation there, so you can understand better, I think. But also you can just give ChatGPT the values. You're just gonna return the values back. So when we calculate the values, it's gonna be 225, and for clock control register is that for T-rise is an actually maximum rise time. As you can see, it's in standard mode. Also you can see it's explain the how to calculate T-rise. But I also put the equation here also. When we do the calculation, we just found 46. After that, when we do our configuration on I2C, we're just gonna be enable the peripheral, as I said before. Peripheral is, I think, 0. Yes, we just give them enable. It's an counter register 1. Just give 1. That's it for I2C init. So we just made an init function to communicate from master to slave. We have to take an address of the slave, as I said before. So first there is a start bit to start to communication, I think. I didn't find. Yes, it's in there. Yeah, as you can see, there's a start bit 8 in the 8th bit. Oh, let me look. Start generation. In master mode, as you can see, we are using master mode, as you can see. So we will just give 1 to start the condition. We'll just give like, we'll just generate a start condition. So after that, we will check this in this code. You will just check the start bit is set or no. So is start bit, let me look the status register. Where is the start bit? Is this 0th bit? Yes, the start bit is in master mode. As you can see, when start condition generated, when this bit is 1, start condition generated. This code actually check the start bit is set or no. So in this code, we just send the address of the slave and the direction. Actually, we just send an OLED screen code, not getting back code. There's just one direction actually in this application, but I put that to just show you. So let me look the address, and there is also 10-bit addressing, but kind of complicated. Let's look at the bit 1. Yeah, address send master. So from master to slave, we will just send the address of the slave, right? So in this code, we will just say to data register the address of the slave. So this is the data register. This is the first bit, the address register. Let's look to the first bit, and we are using a master. So if there's 0, there's a problem. No end of address transmission. So address transmission doesn't end, but if it's 1, the transmission is finished. So is there actually we just slide 1 byte to address bit, and we just put there a direction. It's actually a read or write. Is it read or write bit? This is direction. Bit actually is read write bit, as I said before in the frame. So after that, we will check the flag if it's the address flag is set or no. So let me look. So we will check that, and then we will read the status register to clear the flag. Yeah, we just read the status register to clear the address flag. So after we just made the matching, we will just clear the address flag. So we can, if we want to send more slaves, we just clear the address flag, and for example, I want to send another slave, and it should be like another address, so we just clear that. So to stop the communication, we just give status register, not status register, control register. It's gonna be there, stop bit. It's the 9th. If we just give 1, master mode, stop generation. As you can see, we just put 1, and then communication will stop. To write, we will use an transmitter register. It's gonna be probably a control register, right? No, status register. We will check the data register is empty or not. It's in there, I think. The status register, and TXE is there, the 7th bit. The data register, transmitters. So set when data register is empty in transmission. So first we will check it's empty or no. So wait until that register empty. So after that, we will just write if it is empty, and then we will write data. If empty, we will write data. It's gonna be like that. So in the second one, we write data, and we're just gonna wait if the transfer was finished or not. So this one is by looking at the BTF, byte data transfer finish, bit 2, as you can see. If data not 1, it will return 0. If it's succeeded, it's 1. So in there, we're just gonna wait until it's 1. It's finished or no, we will check that actually. So if you want to send like multiple data, we will actually just use more than one write function there. We will send them each byte in the array. So actually the I2C library is gonna be like that. And for OLED screen, I will just the font. Actually, normally they put in another h.h file, but I just put there. Doesn't matter. So this is for OLED screen. I also write that on my own. So for these things like display off, you have to check the data sheet of the OLED screen SSD. This one, yeah, this is the right one. There is a unique address of slave to OLED screen. So how do I find it? Of course, I check the datasheet. In the datasheet, it say like the either is 1011 or this one. So let's check what is that. 001 1 1 1. So this is this one. Okay. So let's look at the hexadecimal. So it means 3C. And let's look at our code. It's 3C. It's like, okay, matched. But let's look at the other one. So it says that you can either use this one or this one. So we can also use, I think, the other one. Let's look at what is that. I just wonder. 0 1 1 0 1 1 1 1 1 1. This one, I think, 3D. Yeah, for 1 1 1 1. Yes. As you can see, it's on the datasheet of the OLED screen. It says you can use 3C or 3D. So I just use 3C, but I don't think it's gonna be a problem if you use 3D. So let's get to the main function. I just put the clock library, my I2C library, and the OLED screen library there. So I just wrote a code. It's just display on my channel's name, and the 32 is the exclamation mark. So let's write a slide for you, like, let's write subscribe. Let's write S U B S R E, and this. Let's connect our board. I just upload the code. It says, and my channel's name, and but I just, oh yes, yes. Let me. Now it's written my channel's name and exclamation mark. As you can see, it's written my channel's name and exclamation mark. So let's upload the code, and it's gonna be written subscribe to down of the Demirtas. So let's upload our code. Build it. There's no error warning. Let's upload our code. As you can see, I just upload my code, and now it's written subscribe. Yeah, that's it. So for this video is okay, it's enough. So thanks for watching the video. Don't forget to like and subscribe. So take care. Ciao.